All right, so this is lesson 5.4. We're going to be talking about antiderivatives. Of course, I'm Mr. G Math, coming at you live, right? 7202. Most of our calculus life, we've thought about derivatives. But as you move forward in calculus, and you do higher levels of calculus than just even A and B, more calculus deals with antiderivatives, and then sometimes we can call that integration, though that can mean other things too than just the antiderivative, then taking the derivative. So you know the concept anti in front of something, right, is a prefix that means the opposite, right? Yes? Yes. Antidote is the opposite of dote. So here we go. Look it up. So we're first going to warm up by differentiating. So we're going to take the derivative, and then we're going to understand what is the rule to do the antiderivative. And we did some of this work in summer too, but that was a long time ago. So what's the derivative of f at x equals x cubed? And it's the simple power rule, right? The power rule is, and I'm going to explain it again because the antiderivative is the anti-power rule. So the power rule is the exponent multiply in front, right? And then you subtract 1 from the exponent. That language, when we do antiderivative, we're going to be able to know the rule how to go in the opposite direction. What's the derivative for number 2? So they have the same derivative, even though it wasn't the exact same function, right? Number 3, what's the derivative? Again, the same derivative, even though it's not exactly the same function. So it says, what should you get when you anti-differentiate that? So if the derivative is 3x squared, how do I go the opposite direction to find the function? So to go back, we go back on the rule. We're not going to subtract 1 from the exponent. We're going to add 1. So instead, when you add 1, it's going to be x cubed. And then what do? Is instead of multiplying, you divide. And what's the exponent we're going to divide by? 3. So then the 3's divide out and leave you with x cubed. But when you do the antiderivative, you have to include a constant, a general constant that could represent any constant number. Why must I do that? Because it could have been 0, it could have been -10, it could be any number added at the end that when you take the derivative would give you the answer 3x cubed. So I said this in summer, right? That you can't forget the candy. That's what I say. So do you see like the poster up there? Look at the one beside Mel Gibson. What does it say? Don't forget the candy. So when you do the antiderivative, I'm always going to remember, right? To not forget the candy, okay? So when you do that antiderivative, it'll be easy to forget it, but don't, okay? So we have to add c at the end to show that any constant could be added or subtracted to it and you get the same derivative. Yes? Yes. Okay. So this problem can also be written. This is a symbol that you might have remembered in summer or not, but that's the symbol for integration, which can also be antiderivative. So if you see that symbol, which kind of looks like a long, weird S, if you like looked at a violin or a cello maybe like that, right? It has that kind of a symbol carved out. It would be the same answer. So you'd add 1 to the exponent, so it's x cubed, divide by 3, so 3 divided by 3 is 1, and then you can't forget the candy. That's right. You'll never, right? So that symbol, right, is called an integral symbol and tells you to integrate. Antiderivative. The expression which follows it. That expression is called an integrand, just some vocabulary. dx indicates that you're integrating with respect to the variable x, but does not affect the integration process. The big C is called the constant of integration and must be written as part of your answer when you are anti-differentiating. So this is the power rule when you do an antiderivative. So when you integrate, what are you going to do to the exponent? Add 1, and whatever that new exponent is, you're going to divide, and you're not going to forget the candy. If it was a constant, how would you integrate a constant? So k is just a number. The answer would just be kx if you're integrating with respect to x, and then you can't forget the candy. A scalar multiple rule, that if you have a constant that can be factored in front of the integration, you can take that constant in front and then integrate, and that constant then can be tacked on in front at the end. You can never factor out a variable, only a constant. And this is the sum or difference rule, that if you have adding or subtracting, you could integrate each one separately to get the answer at the end. Okay? Okay. Number 4. How would you integrate x cubed? And so what would it be?
4.
Then what would you do? Not yet. What would I do? Divide by 4. What's another way you could write that? You could also write it as 1/4, right? They mean the same thing. And then what are you going to forget? That's right. Don't forget the candy ever, right? Like anyone could forget candy. Or candy. Right? That's right. Never forget about it. Number 5. How would you integrate a constant? 2. It would just be what? 2x, and don't forget the candy. Now, this will be obvious, but I want you to do this in your head always, is when you take the derivative, what should it equal? What it was before, right? What's the derivative of 2x plus c? 2, right? What's the derivative of 1/4 x to the 4th plus c, right? Like you can quickly take the derivative to make sure that they are, right, equal in terms of what you're doing. 6. So add an exponent, and it would be to the 5, and then divide by that exponent. Notice the letters t. 2 would be 2t, and then include the candy at the end. All right, turn the page. No, it's okay. So number 7, how would you integrate that? You would add 1 to the exponent, and then you divide. If there's a number there already, you just divide that number, right? So there's a 2, so it's going to be 2/3. Is it wrong to write that as 2y cubed over 3? No. Both are correct, right? So it's okay to write that. Next one would be y squared. And when you divide, what's 4 divided by 2? And the last one would just be, and then the candy. How can you double check to make sure you did it correctly? You could take the derivative, and it needs to equal, right, what it was before. Here is an example where you should do some basic algebra before you do the calculus. So what's some basic algebra that would make this easier? Instead of x squared in the denominator, you could write it as x to the negative 2. Instead of root x in the denominator, you could write that as x to the exponent negative 1/2. So the exponent 1/2, of course, is square root. It's in the denominator, so it's going to be negative 1/2, right, for the exponent. Now, what would the anti-power rule do? So we're not going to add. We're going to add 1. So negative 2 plus 1. Be careful. And then when you divide, what's 3 divided by negative 1? Again, start with the exponent. Add 1.
3/2. Just kidding.
I know you're kidding. So, when you divide by a half, it means the same as times the reciprocal. So instead of divide by 1/2, if you have a 1/2 in the denominator, how can you write that? What's the reciprocal of 1/2? Okay? So in other words, I was saying that you had x to the 1/2 divided by 1/2, right? Oh, and then what's a better way to write this? Was 2x to the 1/2, that they're equal to each other, okay? And notice that when you add 1, it's now a positive exponent, and a positive divided by a negative stays negative, and then of course the candy. 9. The algebra before the calculus. So what will the algebra look like? The square root of x is the same as x to the positive 1/2, correct? The square root of x can be written as what? X to the 1/2. What's the denominator? That denominator belongs to both. Meaning, the second one would be 1 over x squared. Well, 1 over x squared is the same as x to the negative 2. And now you can do the, well, not quite yet. We're soon going to be able to do the anti-power rule. What do I still need to do here on the left? Because they have the same base, what can I do with the exponents? Subtract them. What's 1/2 subtract 2? 1/2 subtract 2 is negative 3 over 2. Or negative 1.5. In order to subtract numbers, we need common denominators, right? So what would you change 2? So it's a common denominator. 2 is the same as 4 over 2, right? And 1 take away 4 is negative 3 over 2. The second one is ready to integrate. And now can I do the anti-power rule? So what is the anti-power rule? Add 1. What's negative 3 over 2 plus 1? Remember, I'm going to dress up as a fraction for Halloween. That's what scares you. Add 1. Common denominator is 2 over 2, right? So what's negative 3 plus 2? It's negative 1/2, right? When you add 1, and then you're going to divide. Well, when you divide, it's the same as multiplying times the reciprocal. And what's the reciprocal of negative 1/2? So instead of dividing by a fraction, that is the same as multiplying times the reciprocal. How about the second one? Add 1 to negative 2. And when you divide, that's going to change the sign, right? So negative 1 divided by a positive changes it to a negative, but the 1 doesn't change anything, right? When you divide, and then don't forget the candy. So, the algebra before the calculus. All right, so it says, note, put plus c when you integrate, but never when you take the derivative, right? So don't get into the habit always going plus c, only when you integrate. So, sometimes an initial condition is given, which makes it possible to solve for c, so you don't have a c in your final answer, but you actually have a number of what the constant is. So, can we see what happens for that? So, in example 10, you're given the derivative, and you're given an initial condition. That means when x is 1, y is 3 over 2, and then it says, find the function. So, step 1 to find the function is to integrate. How would I integrate x to the negative 3? What would I do with the exponent? Add 1. What's negative 3 plus 1? And then divide, right? By that exponent. And then don't forget the candy. In this question, it says, well, you can actually plug something in now. So in the question, it says x is what number? So where there's an x, I'm going to plug in 1. It also says what y equals. What's y? And f at x is just a fancy way to say y. So we're just going to make it equal to what? Now we can solve for c. 1 to any exponent is equal to 1. And 1 divided by negative 2 is negative a half. Can you get c by itself? What would you do to both sides? Add a half. What's 3 over 2 plus a half? 3 plus 1 divided by 2. So what does c equal? So if I put it all together, let me not get into the other question. When I put it all together, what does the function equal without c? Now I know what c is. So before it was x to the negative 2 divided by negative 2. Could you also put negative a half in front? That would mean the same thing. But I now don't go plus c because I know what c is. What is c? So we can now have this answer when you're given a point on the function. So sometimes you integrate and you're given a point. That point allows us to find what c is. Example 11. It says, take the derivative and integrate this. This is where you need to understand that they're inverses of each other, right? They're opposite directions. So if you take the derivative and integrate, they undo each other, and then your final answer is 5 root x minus 1 over x squared. Someone will still get it wrong. So why is that example there? To remind you that derivatives and integration, right, are inverse operations, right? That they undo each other. And then that's what you're left with. All right, back to an old friend. Position, velocity, and acceleration. It's been too long, old friend. Too long. Let's break bread together again. So, position, if you take the derivative of position, it gives you the velocity. And if you take the derivative of velocity, it gives you acceleration. In the other order, if you are given acceleration and you integrate, it gives you velocity. And if you integrate velocity, it gives you the position. All right, so in this question, it gives you what to begin with? The acceleration. So how would you find the velocity? Auntie, what does that mean? What would I do? What exponent don't you see that's on t? So add 1. And then what do I do with that exponent? Divide. What's 4 divided by 2? What's the integration of negative 3? Negative 3t, and of course, now, they have to give you an actual value for the velocity. Do you see that? That means when t equals 1, so wherever there's a t, I'm going to plug in 1. What does the velocity equal? So I can actually plug in a number for t and plug in a number for v, right? The velocity. And then that allows me to solve for c. What is 1 squared times 2? 2. What's 3 times 1? 3. 2, take away 3. Add 1 to the other side, and what does c equal? So altogether, what is the velocity of this particle? It is 2t squared minus 3t, but now I know the constant, which is 7. How do you find the position equation? So what would that be? 2 cubed, right? Divide by 3. minus 2 squared divide by 2, correct? And the antiderivative of 7 is 7t, and then, of course, the constant. Now, what are we given about the position of the particle? So the position is 5 when you plug in what for t?
2.
This would definitely be one where I say just plug it in your calculator. So maybe you can practice to see if you could even do that in terms of doing that in your calculator, but I'm just going to give you the answer. Yes. So you know that you could plug this in. What do I think you should try to do on your own? Is to try to go and use the menu and algebra button, right, where you solve an equation. And can you type that in and solve an equation with your calculator? If you did that, C is equal to negative 25 over 3. So you can try that. Make sure that's right. That means when you put it all together, what's the position equation? 2/3 t cubed minus 3 over 2 t squared plus 7t minus 25 over 3. Where was the initial position of the particle? And it's the constant you came up with. If you plug in 0 for t, you're left with what that big C is, right? So by doing that work, you actually know the initial position, right, of the particle, not just when it is at 1. Show the page. Hey, does anyone love physics?
Yes.
That's right. Has anyone taken physics? Yay. Here's your physics moment for the day. Given that on Earth, the acceleration of an object due to gravity is negative 32 feet per second squared. Negative indicates a downward, right, in terms of gravity. Develop an equation for velocity and one for, and then the initial velocity, just make it v0. And then we'll do the same thing for a position. So negative 32 feet per second squared is the acceleration of gravity. What would the velocity be? And we're going to integrate that. Well, integrate negative 32 and you get negative 32 t, and then we have a constant. Now, they said don't write down constant. Instead of the word c, they said, why don't you just put down v sub 0, right? Now, when you go v sub 0, that just means the initial velocity. So when you plug in 0 for t, what would the velocity be? We don't know what it is. So that's just a symbol that means initial velocity. How would you find the position equation? What would you do to negative 32? Add 1, and it's now squared. Negative 32 divided by 2 is negative 16t squared. Whatever the initial velocity is, that's a constant. What letter would be with it? T. And you have the constant, and it said the constant's going to be your initial position, which says is s sub 0. This equation is used often in physics to describe the motion of an object falling. That initial velocity gets fired up in the air, and how long does it take to hit the ground kind of questions? That equation's used for that. So note the two equations there may be used for any motion affected only by the Earth's gravity. Often questions, like something's been thrown off a cliff, or a rocket ship, like North Korea, right? Going like that. Oh, that's the future. So, that's your lesson.